Hello and welcome to another Developer Essentials video. So this time around we're going to be taking a look at the area of lighting. Now this is quite a large area. There's a lot of different things that we could be looking at for this. So we're going to just be looking at some key main considerations with it. And we're going to be looking at that with the built-in pipeline. Now with things like the universal render pipeline or the high def render pipeline, there are some things that do change. In particular on the high def side, there's different controls. The lights work a little bit differently there, but a lot of the fundamentals are similar there. So we're going to just focus on built-in, and we're just going to focus on some key aspects to this because it's a huge field with lighting. So we just want to look at some of the key essential bits there for it. So I've got just a very, very basic scene set up, and with this, our default scenes, we always have a directional light in it. So good starting point with this is getting an understanding of the different types of lights that we've got. So we have this idea of a directional light, and we can see the different types here. So with these, directional light doesn't actually matter where it's positioned in the world. What matters is this rotation of it. And we can see it shows where it's drawn, and that is changing the shadows. So lighting is intrinsically linked to our shadows there. It's also changing which faces of the cube are more lit up. So that's what our directional light is doing. I'll just set that there like this. We've got more controls than just that with our lights. So we can control things like the color. So that allows us to adjust exactly sort of the tone that we want for the particular lighting, so we can customize that. We also have the intensity, which that in particular, if we're using things like bloom, that intensity can really sort of enhance and the bloom effect there. So things that are lit more brightly are going to more strongly trigger that sort of bloom effect. And we can see the adjustment for the indirect lighting, which is not generally going to do too much in this particular case. We can control our shadows. So we can have soft shadows, which this is best illustrated if we go in nice and close to soft shadows. We'll get these sort of feathered edges here. If we switch to hard shadows, then we get very, very crisp, sharp edges here. It's either in shadow or not. There's not a blend that happens there between it. And we can also turn off shadows entirely, but obviously as soon as we turn off shadows, then it can kind of feel a little bit like things are floating. So soft shadows is the default, and there's obviously quality settings that we can adjust with this as well. But some of how this interacts with lighting can also be controlled with on the cube itself. So cube itself has controls here for lighting, in that we can control if it receives shadows. So for example, if I set up another cube and offset it, like this, we can control if this first one receives shadows, which will mean whether other things are able to cause it to be shadowed or not. We can also choose whether it casts shadows, and we have a couple of options here. So we have off, where we can see it casts no shadows at all. We can also go for two-sided, which we're not really going to notice a difference in this particular case. That would be more for something like a quad or that, we'd see a difference. We also, and this can be really handy, we have shadows only. So this allows us to have something where we don't see it in the world, but we see the shadow that it casts. That can be super powerful. So for example, you could do that where if you've got a first-person game, we typically with that, at most, you might see the arms of the character, maybe the feet, but you want the shadow to be the entirety of the character. So you can then have a mesh that is shadows only, that is then able to be casting that shadow, but you're not actually seeing it. So shadows only can be really, really handy. So if I switch this to, I'm going to move one over here and make it shadows only. just so we can see that. And then let's also have one here that we will turn off shadow casting on, just so we can kind of see the differences that we get there. So shadowing is controlled typically on the actual mesh itself, but we also have settings in terms of these materials that can control how they interact with lighting. So for example, our ground here, you'll notice the ground, if I face in the direction sort of towards the light there, we're getting these slight highlights, these specular highlights they'd be referred to as. So adjusting some of our settings here for the material, like how metallic it is, its smoothness, these will actually control some of that behavior in terms of those, how the lighting is interacting with the surface. We can also get here and turn off things like specular highlights. So immediately we lose that aspect. Reflections, we're not going to see much of a difference in this particular scene, but specular highlights in particular will notice a big difference. So the material itself has options there. We can also, if I change the cubes, can see in terms with those, we could switch to an unlit shader. In which case, an unlit one both receives no lighting, so it's always at its whatever the colors are assigned to it. Those are always going to come through with full intensity. So if it's unlit, then there's no lighting, there's no shadowing on it, and not just that it is actually not able to receive lighting or shadows, it also doesn't cast light or shadows in those cases. So, okay, that's what we get with directional lights. Now, we have a few other types of lights that we can create. So let's take a look and see what those ones actually do. So we also have spotlights. Now, our spotlights, they do have a location. Location matters for them. So let's move this up. And what I'm going to do is I'm going to change the color of this to a really bright green. And then we can see the spotlight applies in a particular cone, which we can adjust that cone. We can adjust the intensity of it. So it's going to control how brightly it's going to be affecting the particular objects. We can adjust the angle of it a bit. So if we moved it over here, then we could get here and rotate it so that it is then facing like that. And if we turn on shadows, so that'll be able to cast shadows as well. So we can have multiple directional lights impacting on the shadows, and we can see there is a bit of overlaying of stuff that will happen here. Not always in a way that is realistic. Like this, we wouldn't really see typically the shadows sort of here, they would get bled out. But in this case, we're able to sort of see those additional bits of shadows there. So those are our spotlights. We also, on top of that, under lights, we have point lights. So as spotlights radiate in a cone, a point light, and we'll bring this so that it's up, a point light radiates in a sphere, and we can kind of see the sphere, which we can control that range. And so this allows us to, if I change the color again, so we have that one's casting red line, and again, we could have shadows on with this. It is going to be applying a bit of light to that, so we can just sort of see it. Now, so we've got spotlights, we've got directional lights. We also, under lights, we have these things called area lights, which an area light, that we actually won't see anything initially. And the reason we won't see anything is because area lights don't support real time. So these are the lights here. We can see point light, spotlight, directional light. Those all have these different mode options. So real time means that as those lights are moved while the game is running, then the actual lighting, the impact on surfaces is recalculated. So if I grab my different lights here, then moving these, it will actually change the scene. So as these actually move, everything changes and updates. So real-time lights, that will happen with. Area lights only are supported in this baked mode. So the idea behind baked mode is it does the lighting calculations as part of your level building process. So it's an explicit thing where you tell Unity, build the lighting. And so it generates the lighting information and stores that alongside the level. What that allows it to do is it can use more complicated, more sophisticated approaches for calculating the lighting there. And it then means that at runtime, it's not having to do those lighting calculations. So it's a lot faster runtime. The catch with that, though, is it's not going to be able to handle if those lights need to move, because the lighting information is already baked based upon the positions that they were in. So you do have mixed ones, which are a bit of a blend of both. But so baked lights, you're not going to be able to move those around. So for example, if the player had a flashlight that they could shine around the level, you couldn't do that as a baked light. You would have to do that as a real-time light. But if you had a scene where none of the lights can be moved, then you could actually pre-bake that lighting. So the process for doing that, and we'll take a bit of a look. So what I'll do is I'm just going to create a little bit of a barrier between all of these lights, just because we've got a lot of different lights here and we don't want to have too much in the way of them interfering with each other. So we're going to create just a bit of a wall here. I'm going to make that higher. So that then what I can do is my area light can be lowered a little bit. So area lights, we'll see how we actually can work with those, but because they have to be baked, that does mean that it is a bit more of a intensive process from a level design point of view, that we set it up and then we're needing to go and bake the lighting. So to actually bake the lighting, if we go to Window and under Rendering, we have Lighting. So lighting has a bunch of different options here. We can set up a whole bunch of lighting settings for our scenes, which will control how lighting gets generated. We also have some options here in terms of the environment side of things. So in built-in, we actually can control stuff like the ambient lighting for the environment. So we can be controlling whether it comes from the skybox. We can also do just a fixed color one. And this allows us just to set, if I go for yellow, see we get just a vague yellowish tinge there to things. So this is a way for us to be able to control sort of what the ambient lighting looks like in the environment. Now, if I have my area light there as a baked one, so it's the only baked light. Now, none of my geometry is moving, so ground definitely won't. So I'm going to make the ground static. And then to bake the lighting, so we've got our scene and we have the option here to generate lighting. You might notice that the audio at this point isn't really quite matching up, and the reason for that is because this is actually a re-record of just the audio part. The generation of the lighting is actually such an intensive process that it was corrupting the audio that was generating for this part. And that was one of the things that I was highlighting here, that we do need to be mindful that when we're generating lighting, that it is a very intensive process. Even the really simple scene that we've got here, where it's just a few cubes, a few very simple objects, a simple light setup, it's taking a couple of minutes and on a decently spec computer. So it's a fairly intensive process there. Part of that is why we have that auto generate option is off by default, because that's something that could be quite intrusive when we're actually doing our process of editing and building the level, of if that was actually running and continually sort of operating in the background. Because if we were modifying the scene while we were actually generating the lighting, then that will actually invalidate potentially the stuff that's being generated. So we kind of need to, when we generate the lighting, let it generate and then just actually wait to let that finish. So we can see it's finished actually doing the generation, and we can see even for a fairly small setup, it's taking up 2.7 meg. We can actually inspect our baked light map. So the data for these gets generated alongside there, so we can actually see that. If we need to, we can just sort of view the different things that are being affected. So we can see the baked light map. This is the one that's controlling it. And so that gives us, that data there, but we're not seeing our area light in there. We configured it. You can see that it should be applying to everything, but we're not actually getting any light appearing from this. So that's something where what we need to do is firstly, I'm going to make my area light larger. And to do that, actually, not the scale, I need to adjust the width and height here. So I'm going to make that more like 5 by 5. And then I'm going to position a cube that is going to be directly below that area light. I'm just going to use the easiest way for positioning this, which is just like that. And then we move it there. So this, because I want the area light affecting it, I'm going to make it static. Going to leave that there. So this one should be able to be affected then by that area light, which is good. So for the area light to work, we need to make sure the different things in the environment that we want it to be taking into account are static. Once we've done that, we can then tell it to generate the lighting. So again, under our lighting setup, we can tell it to generate. So again, the audio's been corrupted a little bit here. So this is an insert that's happening afterwards. What I was highlighting was just that generation process, even when it's already generated it before, is still going to be intensive, even in a case like this where it's a small update. In theory, we don't really notice much of an impact from the area light, but what we can do is we need to make sure the area light itself is set to static. And then to make it a little bit easier to tell that stuff is happening, we can change the tint color here. And then if we bake the lighting, so we are needing another audio insert, unfortunately. So what I'm highlighting is that area lighting is very soft and sort of subtle in its appearance, whereas our point lights, our directional lights, our spotlights give really clear sort of sharp definition. We've got very clear shadows, very clear areas that are illuminated, but area lights are a lot more subtle. It's a very soft lighting that it's applying to a section of the scene. So it can be a little bit harder to spot, but it is something that it will make a big difference to the scene, in particular if we're trying to get that really nice sort of soft lighting. That can actually be hard to achieve with the other light types, whereas the area lights, we can achieve that, but we won't typically get the really sort of sharp, intense light illumination aspects and the sharp shadowing. And we can notice if we look at the cube, there's a little bit of a tinge of red on the cube. And as we add more area lights in, it's going to mean our baking process takes a lot longer, which is something we have to be really cautious of, because we've got a really simple scene here. And even with that, the overhead is enough that it's taking a couple of minutes, and the bake's quite expensive, and it's actually impacting the performance of the computer. So we've got our different types of lights. we really need to understand the performance considerations for these. So what I'm going to do is I'm going to enable the stats view here. I'm just going to run this. So this is a fairly ideal case. The camera is stationary. So one of the things that we'll notice is some key things we're looking at. So frames per second is important, but things that drive that. So we can see here the number of batches. So even though these cubes are all the same, they're not actually managing to get any saving with them. And so there can be different causes for that. If I go to the materials in the cube, then I can turn on GPU instancing, and we can see if that manages to get any saving. So we were sitting sort of 59. So that saved a bit. And so we can see it's managing to get some saving there, but we're still getting quite a few. We can also, in our project settings, check if dynamic batching is enabled. So dynamic batching, turning that on, can also help as well. So batching often needs, without dynamic batching, it needs the objects to be marked as static. So we turn on dynamic batching, we've saved even more again. So we went from 59 down to 40 odd, now down to 36 odd. So we've managed to get a few savings there. But let's see what happens as I add in more lights. So when we get a setup where we've got a more complex environment. So we're currently at 36. Well, let's add in another light. We immediately jump up in the number of batches, and every light I add in is going to have an increase, but you'll see it's stopped increasing. And not only has it stopped increasing, you'll notice this light isn't doing anything. It's not actually causing any lighting in the scene. So it's hit a point where the lights have stopped doing anything. And if we go to our project settings, and if we take a look at under our quality settings, pixel light count is the thing that is at play here. So pixel light count is the number of lights that are going to be doing those full calculations and affecting the environment. And so as soon as I hit 4, it was going to stop actually doing anything with new ones. And you can imagine in a large environment, if you do need to have a lot of sort of dynamic lights, that might need to be really high. So let's do something potentially really not good and ramp up the number of lights there. And I'll do this while running, so I have an easy way of just cleaning that up. And we'll see how it starts to get more expensive with every new one. So in this case, every new one is adding in quite a lot of extra batches there. And if I pick just a cube, so a cube has 6 sides. So 6 sides is going to correspond to 12 triangles. So we add that in. As soon as we have another one, we have 10 more batches. So for a really simple object, it's adding in a whole bunch of extra batches. So the more lights, the more complex our geometry, it's rapidly scaling up to get very expensive. And that's because rendering mode wise, if we take a look at our camera, so it just says rendering path, it's using graphics settings. And well, if I go to the graphics section, then I can take a look at my different tier settings. So rendering path for each of these is set to forward. So let's take a look and see. I can manually override it here. So I've got the 2 main ones that I'm concerned with, the forward or deferred. Forward's what it's currently using. What if I switch that to deferred? So forward, we know it was 32 as we're adding in ones that was rapidly getting more expensive. Let's switch to deferred, and then now let's do a similar test of putting in more lights. So we're at 32, add in another light. So it is still continuing to go up. And the more ones we add in, the more it will go up to. So with this, we've got up to, or at point light number 7, and we're sitting at 103. If I switch this over to forward, it will be more. So deferred, it still goes up. So there's still an increase for each light that's added in there, but it is going to be less. So deferred is more efficient when you have multiple lights in the scene, in particular when you have a lot of lights in the scene. Deferred is a lot more efficient. However, the catch with that is that the way transparent objects have to work in deferred is transparent objects have to be rendered in a separate path. So it can mean that you can potentially run into some artifacting with transparent objects if you're not careful. Things like some post-processing effects are also impacted, where some of those may not work quite the same in deferred. So you potentially need to make some changes there with that. But the key is if you're using lots of lights, in particular if you have lots of lights and they need to be real-time, then you're likely going to need deferred rendering. If you have lots and lots of lights, but they don't need to be real-time, and you can afford the time there for the light building, then you could make them all baked lights, and you could bake that lighting information there so that you're not having to generate it at runtime. It is going to increase the size of the level, in that extra data needs to be stored alongside it. So it won't be directly in the scene, but it'll be stored alongside it. So there is extra data there, but it means that the runtime performance is going to be significantly better. So these are the key things with the lighting in Unity, main things to be aware of. So our different light types. Directional lights give you essentially provide sort of illumination from a particular angle. They are not impacted by where they are in the world. It's purely based upon the direction that light is facing. Point lights are used for individual things like a bulb or something like that. Area lights give you soft lighting. They can be useful for things like fluorescent tubes, stuff like that. And spotlights are for when you would have a spotlight in the scene. Now, most of the light types support different modes. Area lights are the only one that they only support baked, so the data has to be pre-generated. Point, spot, directional lights, those all can be set to real-time, baked, or mixed. So real-time is if those lights are moving around generally. If you're wanting, so not just changing the intensity, but if you're wanting to move the lights around, then you're typically going to need those to be real-time. If they're stationary, then you can likely have them set to baked. And you also have the mixed mode, which gives you a bit of an advantage of both. But you also get a bit of a compromise of both, in that it gives you a lot of the benefits of baked at runtime in terms of performance, but it is a bit slower. And real-time, it gives you some of the benefits there, but it also uses a bit more memory than real-time would, so it kind of sits in the middle. So you have the different light types. If you have a lot of different lights in the scene, then if you're in the default rendering path, so using graphic settings and your default rendering path is typically going to be forward, what that will mean is you are constrained by the pixel light count. So once you hit that number of real-time lights, then the least relevant light is turned off, which is often going to be ones furthest away. So the least relevant light is turned off. You can increase that pixel light count, but the more complex your scene, the more expensive that ends up becoming. So there are some things you can do to help with that performance. We can turn on, as we saw, the dynamic batching, and we can also in the material turn on GPU instancing. That can give us a bit of saving there, but it will still be more expensive. If you're needing a lot of real-time lights, then you want to typically look at using deferred rendering, because that's going to scale better with the increasing number of lights. It still gets more expensive, so it's not a thing where it's a case of like, cool, I can have 5,000 real-time lights all visible at the one point in time. No, you can't. It's still going to be more expensive, but it's not going to scale up as rapidly as it does when you're using the forward rendering path. We also saw we have a lot of control in terms of things like shadowing and that, and how the different settings work. They're spread across a lot of different areas. So the lighting itself, the actual light, controls the type of shadows it generates and whether it generates shadows. On the actual object itself, you control whether it can cast shadows, whether it can receive them, whether it actually is just shadows only. So you've got different options there in terms of how it behaves. The shader being used on the particular material impacts it as well. If that shader is an unlit one, then you will actually get no illumination of the object, and that object will not cast shadows. So there's lots of different pieces there with it. The key stuff I really recommend there is don't go too overboard initially with adding in lots and lots of lights. Add in the essential ones that you need. Get it working. You can generally get a good sense of how the lighting is going to look in the editor, and do that before you commit to a really long bake, for example, for it. You want to be really cautious with how long the bake times can get. As we saw for even this level, it was a fairly lengthy time just for a single area light in there. So experiment with it, but be mindful of the fact that this can get very expensive very quickly. It's also, this is in the built-in pipeline. In the high def and lightweight pipelines, also the universal pipeline, we have a lot of different controls over lighting, and a lot of that is based on using its volume system. In particular in HDRP, the volume system there is used for controlling a lot of aspects with lighting and shadowing, which means you can have it behave differently in different parts of the level. So those are ones to check out. The same principles still apply. It has still many of the same light types, but what you'll see is whereas these have a intensity and color and things like that you're adjusting, those in particular in HDRP have very different settings because they're giving you a lot more control over how the light is going to look. So dive in, experiment with it, see the kinds of things you can create. We've looked at the core bits here, but there's other things you can look at, like the idea of light cookies, which is changing the shape of the light. So this thing you see with torches, where it doesn't project this solid cone of light, it actually projects it with a little bit of a pattern. That's a cookie. So you can set up light cookies there for it by setting up a texture for it. So dive in, experiment, see the kinds of things that you can create with it. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects. They're freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.